Okay, for these notes, I'm going to show you how you can do some of these integral problems, taking advantage of your calculator and some of the stuff your calculator can do. So this was one of the same problems we did on the notes from section 6.1, find the area between these two parabolas. So one thing you'd have to do on this one when you're setting up your integral to figure out the area is you need to know what are those limits going to be, where do these intersect, and we looked on the last notes that you could set these two equations equal to each other and solve it out that way mathematically. I'm going to show you on the calculator how you can also do that. So go to your calculator, bring up your graph part by hitting the y equals button, type in these two functions of x squared and 2x minus x squared. And then once you have them graphed, hit the graph button and you can see the graph of these two. To see where these intersect, we want to use that intersect key. You can see these do, it's kind of narrow there. If you hit zoom and go to this number 4 one, it's kind of a closer view of this. And you might be able to tell that it's 0 and 1 on here, but sometimes you can't. So what you want to do is go to the calculate menu, so hit the second button and trace, so it selects the calculate one, and on top of that, go down to this intersect one, number 5 here, and that can tell you where these two graphs are going to intersect each other. So what you can do is use your left and right arrow key, put it near that intersection point, hit enter, do the same thing with the second curve and get it near that point, hit enter, and then it's going to have you say, it's going to say guess on your calculator, hit enter one more time, and it tells you, yep, 0, 0 is the place those are intersecting. So now we know this is 0. You can do it a second time and figure out that other intersection point. So again, go to calculate, select the intersect, use your left and right arrow keys, put it near that other intersection point, hit enter, do the same thing on the second graph, that's close enough, hit enter one more time, and you can see 1 is the other location. Okay, so once you got those, now you do have to know some of the stuff we talked about again. You want to subtract and take the area of the, or the equation of the graph on top minus the equation of the graph on bottom. So in this case, we got this 2x minus x squared graph minus this other one, and if we integrate that, that should give us the area between those two curves. We can certainly simplify this to down to 2x, and we got a negative x squared here minus another x squared, so that would be negative 2x squared. All right, now we've gone through and we know we can do the antiderivative now and solve that, and this one's not that hard. But you can do integrals on your calculator too, and I'm going to show you how you can do that, definite integrals. And so what you want to do, go back to your main screen. If you hit this math button over on the left-hand side, you want to go all the way down and find on your calculator this one that says FN INT, INT standing for integral. And if you select that one, on your calculator to pop up like this. Now you want to enter both of those two limits, so enter 0 and enter 1. Hit your right arrow button, and now you're going to type in the function that we're integrating, so 2x minus 2x squared here. And then hit your right arrow button one more time, and in this thing we got to put an x because we want to enter in terms of x here, so we want dxr. And now if you hit enter, your calculator can evaluate definite integrals. So we get 0.3333 repeating, or if you hit math fraction, you can see as an exact answer that's 1/3. Now on a test, you still want to make sure you go through, show your work here of finding the antiderivative and so on, but it is a nice way to double check your answer. Now, the nice thing about this is you can check your answer. It won't work for all these in order to get exact answers, like example on this one that we had done from the notes. Your calculator can give you an approximate answer, but when you start dealing with stuff like e to the x with those exponentials or sine and cosine, it won't always give you the exact answer if the answer involves e or pi or something like that. It can approximate it, so it's a good way to check and see if you got the right answer, but you still have to go through and do the antiderivative in order to find the exact answer. But it's a nice way to double check and make sure you got the correct solution.